All right, let's take a look at lesson 8.3, parallelogram proofs. Just make sure that you're opened up to your note packet and that you've written down this title. As we begin, here's our learning target. I will write two-column parallelogram proofs. So before we begin, let's just recall our definition. What is the definition of a parallelogram? And you can write this down in the blank. A quadrilateral, that means four-sided polygon, in which both pairs of opposite sides are parallel. This is what we're going to base the majority of our proofs on. In order to prove that something is a parallelogram, we're going to have to establish that both pairs of opposite sides are parallel. All right, let's go ahead and start the first example then. In example 1, it says use the definition of a parallelogram to complete each proof. Well, like normal, we begin a proof the same way. We begin by restating all the given information. Now, there's technically two pieces of given information here, right here and right here. I'm going to go ahead and write them down as one line, if that's okay. We're going to say angle BAC is congruent to angle DCA, and then just put a comma or a colon here, and then say angle BCA is congruent to angle DAC, and I can mark that's true because it was given. It's also important for us to mark the diagram based on the given information. That's going to help us make decisions about how to approach the proof. So angle BAC is going to be this angle right here, and it's congruent to angle DCA right over here. We've also found that, angle BCA, that's this top angle here, is congruent to angle DAC down here. You'll note that these are alternate interior angles, and when alternate interior angles are congruent, we can then establish that we have parallel lines. That's going to help us get to our conclusion that this is a parallelogram. So let's mark out for statement 2 that side BC, you can even label it with me, is parallel to side AD. Side BC is parallel to AD. Likewise, we can go in the other direction. We can say that side BA is parallel to side CD, and you can mark that on the diagram and also write it out. BA is parallel to CD. And the reason that those sides are parallel is because of the alternate interior angles converse. The alternate interior angles converse. So a reminder, when you are proving that lines are parallel because of angle relationships, that is a converse. If instead you already know that something is a parallelogram and you're using that information to prove something about angles, you would just state alternate interior angles. But because we're using this to prove parallel lines, we use the word converse. Well, now that we've established that we have two pairs of opposite sides parallel, well, that's the very definition of a parallelogram. So we can finish our proof then with line 3. We can state ABCD is a parallelogram. Parallelogram. And the reason why is the definition of parallelogram, which we have stated at the very top of the page. All right, let's try another one. Let's look at example 2. In example 2, right, we're given this diagram and we're told that WX right here is congruent to YZ. We're also told that WZ, this side right here, is congruent to YX. And we're told to prove that this is in fact a parallelogram. First, let's go ahead and copy down our given information. And I'm going to go ahead and put it on one line. I'm going to say WX is congruent to YZ, a little colon here, and WZ is congruent to YX. The reason why is because it's given. In order to prove that this is a parallelogram, we need to establish that we have parallel lines. But in order to establish that we have parallel lines, like in number 1, we need to show alternate interior angles are congruent. Here's the thing though, none of the given information told us about the angles. So we're going to take a slightly different approach. You might also recognize that there is reflexive property going on here. Let's go ahead and mark in number 2 that XZ is congruent to ZX. Basically, it's congruent in both triangles because of the reflexive property. reflexive property. When we do that, we can then establish that we have two congruent triangles, right? We could call this triangle number 1 and triangle number 2. They are congruent to each other by the side-side-side congruency postulate. So statement number 3 can say that triangle, all right, we'll name the top triangle just XYZ, is congruent to triangle, now we have to name this in the same order, XYZ went from 2 hash marks to 1 hash mark. In the same direction then would be ZWX. ZWX. And the reason that these are congruent is because of the side-side-side congruency postulate. Knowing that then will allow us to establish that there are pairs of congruent angles. So let's take a look. I think we know that this angle here is alternate interior with this angle here. And now I know that those are congruent. Remember, corresponding parts of congruent triangles are congruent. We often abbreviate that as CPCTC. Corresponding parts, right? Angle X here and angle Z here of congruent triangles are congruent. So let's mark this, all right, as statement 4. We can establish that angle, we can't quite call it X because there's multiple angle X's. So we'll say angle WXZ is congruent to angle YZX. In the same way, there's another pair of alternate interior angles congruent because they are corresponding parts of congruent triangles. We can say that angle YXZ is congruent to angle WZX. The reason why is that corresponding parts of congruent triangles are congruent. Well, now we have justification for parallel lines. Alternate interior angles are congruent. We can now establish, you can even mark it on your diagram, that this side is parallel to this side, and this side is parallel to this side. And we'll write that down now. We can say that XY is parallel to WZ. Maybe put a little colon here. And we can say that XW is parallel to YZ. The reason why, just like in number 1, we can say that's true because of the alternate interior angles converse. Again, we're using the fact that there are alternate interior angles congruent to prove the lines are parallel. That is, in fact, the converse. And then finally, we can establish then that WXYZ is a parallelogram. And the reason why is because of the definition of parallelogram. All right, let's try a few more. Let's take a look at example 3. In example 3, we've got something very similar. Let's mark up the diagram. We know that PQ is congruent to RS, and we also know that PQ is parallel to RS. Let's jot down those given pieces of information, right? PQ is congruent to RS, and we'll put a little colon here, and we'll say that PQ is parallel to RS, and that's all true because it's given to us. Now remember, we want to show that there are two pairs of opposite sides parallel. We have one pair, we need to establish the next pair. Because we can see there are some parallel lines here, we can observe some alternate interior angles that would be congruent. This angle right here is formed by this parallel line and a transversal. This angle right here is formed by the other parallel line and the transversal. So statement number 2, we can say that angle QPR is congruent to angle SRP. And the reason why is because these are alternate interior angles. Notice this time I don't write converse because we already knew the lines were parallel. We're using the fact that those lines were parallel to prove something about the angles. The other thing is, in order for us to establish that this side is parallel to this side, we're probably going to have to prove the triangle's congruent like we did last time. So let's mark reflexive property. Statement number 3, we can say that PR is congruent to RP. Reason why? That is the reflexive property. And it doesn't really matter what order you write those letters. If you're wondering why I'm reversing it, it's just because the triangles have been flip-flopped as you look at top and bottom. But you could write PR is congruent to PR, and that's perfectly fine. Now that we've seen that, we can prove that triangle 1 and triangle 2 are congruent by side angle side. So let's establish that in line 4. In line 4 then, we can say triangle, we can name the top one whatever we want, I'll call it PQR, is congruent to triangle. Now let's make sure we get this right. We called the top one PQR, that was one hash mark, then no hash marks. Then we need to call this one RSP, triangle RSP, and that was because of side angle side congruency. Okay, now that we've established that these two triangles are congruent, that means that all corresponding parts of these congruent triangles are congruent. We can then say that this angle here and this angle here is congruent because we know CPCTC, corresponding parts of congruent triangles, are congruent. So now let's name those two blue angles. If I name this one on the bottom left, I could call it angle RPS. Angle RPS is congruent to angle PRQ. We know those are congruent because they are corresponding parts of congruent triangles. Well, next, now that we have these alternate interior angles congruent, we can now show that QR is parallel to PS. Let's write that down as our sixth statement, right? QR is parallel to PS. We know that because of the alternate interior angles, notice converse. If we're using angles to prove lines parallel, that's the converse. And then finally, you'll notice that in our diagram we can see two pairs of opposite sides parallel. Well, that means that we can finish up our proof. We can now establish that PQRS is a parallelogram because of the definition of parallelograms. All right, let's go ahead and flip the page. Let's look at a few on the back. A few other properties of parallelograms are now listed at the top of the page. You'll notice opposite sides are congruent. Opposite angles are congruent. The diagonals bisect each other, and adjacent angles are supplementary. Now, you'll notice in number 4, what's given to us is that this is a parallelogram to begin with. So that's an interesting beginning to our proof. This time we're kind of working backwards. Let's write this down. JKLM is a parallelogram. We can say that's true because it was given to us. But now we need to work towards establishing something else. We need to prove that JK is congruent to LM and JM is congruent to LK. If all we have to begin with is that JKLM is a parallelogram, let's go back to the definition of parallelogram. If you remember, parallelograms have opposite sides parallel. So let's mark that on the diagram. Like this and like this. So we can now establish that JK is parallel to ML. Likewise, we can establish that JM is parallel to KL, all because of the definition of parallelogram. Knowing that allows us to mark some alternate interior angles congruent. I know that this angle here would be congruent to this one because they're alternate interior angles. I also know that this one on top will match this one on bottom because they're alternate interior angles. So let's name those now. So we can say angle KJL is congruent to angle MLJ. Likewise, we can say that angle LJM would be congruent to angle JLK. And the reason why is that those are alternate interior angles. Notice I don't write converse. I already know that this is a parallelogram. Well, if I know all of this, I can now establish that these are congruent triangles. We've got angle, angle, and of course, we can do reflexive property in the middle. So let's do that. we can say that JL in one triangle is congruent to LJ in the other triangle because of the reflexive property. That then allows us to prove that these two triangles are congruent, as I mentioned earlier. So we want to say triangle something is congruent to triangle something because of angle, side, angle, congruency. Now let's name the triangles. The top one I can call JKL, JKL. And if I look at that order, J to K to L, that's one arrow and then two arrows. So I would need to name this one LMJ, LMJ. Well, now that we've proven that these two triangles are congruent, look at the segments we're trying to prove congruent. We are trying to establish that JK is congruent to ML and that JM over here is congruent to KL. We know those are congruent because of CPCTC. Corresponding parts of congruent triangles are congruent. So we can say that that's true. JK is congruent to LM and JM is congruent to LK because of CPCTC. All right, just a few more and we'll be finished. Let's take a look at number 5. In number 5, they tell us that this is a parallelogram, so we can begin by marking our diagram by showing that these two sides are parallel and these two sides are parallel because of the definition of parallelogram. And let's write down our given information. CDEF is a parallelogram. And we know that's true because it is given to us. Let's see what we're trying to prove in this example. They want us to prove that angle DCF and angle CFE are supplementary. If you're wondering where those angles are, well, DCF is here and CFE is right here. Now you'll notice that crosses over into the other triangle, right? But all of angle C and all of angle F are supplementary. Well, first thing to establish would be that CD is parallel to FE. Then we can say that these two are consecutive interior angles adding up to 180 or being supplementary. So statement 2, we can say that CD is parallel to FE because of the definition of parallelogram. We had already marked that on our diagram. And then finally, we can complete the proof. If we know that these two sides are in fact parallel like we marked, we know that angles C and F, for lack of a better name, add up to 180. So number 3, we can say that angle DCF and angle CFE are supplementary. And the reason why is because they are consecutive interior angles, and consecutive interior angles add up to 180 when you have a pair of parallel lines. All right, let's wrap things up by looking at number 6. In number 6, it says that RSTU is in fact a parallelogram, so we'll mark it like this. RS is parallel to TU, and RU is parallel to ST, like this. And they want us to establish that angle U is congruent to angle S. That would be this angle here where I have a little star and this angle here where we have a little star. Well, let's go ahead and write down our given information. We know that RSTU is a parallelogram. And we know that's true because it in fact is given to us. Now as we move forward, we want to establish those parallel lines that we marked on the diagram. So let's write that down. Let's say that RS is parallel to TU, put a little colon, and we can say that RU is in fact parallel to TS. We know that's true because of the definition of a parallelogram. Remember what it said earlier, a parallelogram has two pairs of opposite sides parallel. All right, we've gotten all that marked. In order for us to show that angle U and angle S are congruent, we probably are going to take the approach of proving triangle 1 congruent to triangle 2. Well, how are we going to get there? First thing I notice is if I have these pairs of parallel lines, I would know that this angle is congruent to this angle, and this angle here is congruent to this angle because they're alternate interior angles. So let's take that approach, right? We can say that angle SRT is congruent to angle UTR, We can also say that angle URT is congruent to angle RTS. Those are just the angles that I had marked there. We know those are congruent because they are alternate interior angles. Notice I don't write converse. If I know something's a parallelogram, I don't write converse. If I'm using the fact that those angles are congruent to prove a parallelogram, that's when I would write converse. Okay, so we've got angle, angle, and then we can get side, of course, by using reflexive property. So statement 4, we can say that RT is congruent to TR because of reflexive property. Reflexive property. You can see now how we can prove these two triangles congruent. We've got angle, side, angle. Again, angle, side, angle. You could even write it up here like we've done before. And now let's write down that our two triangles are congruent. Triangle, RST, that's what I'll name the top triangle. RST, I'll name the bottom triangle TUR. It's congruent to triangle TUR. And again, we know these are congruent because of the angle, side, angle congruency postulate. Finally, if I have proven that these two triangles are congruent, you will notice that angle U and angle S are corresponding, right? Angle S and angle U, for me, both fall in the middle. So statement 6, we can say that angle U is congruent to angle S simply because corresponding parts of congruent triangles are congruent, or CPCTC. All right, thanks for watching.